I'm going to do section 3, significant figures. This section is where a lot of students struggle a lot and typically lose a lot of points on their exam because every calculation you do in chemistry, you always have to watch out for significant figures. And doing math throughout high school, we don't do that. We just round up whoever is comfortable with us. But here, it does matter in chemistry. So for me, I recommend for you guys to do as much practice as you can by looking at the textbook and seeing in the back of that chapter, usually chapter 1 or chapter 2 with significant figures practice, and just keep practicing until you really, really master it so you don't miss those silly points, on your exams or homework. So I'm just going to go over the rules real quick. Or actually, you guys can read this. I'm not going to waste your time. So what I'm going to do, I'm going to just make a small chart here, a cheat sheet. So let's say number 1, any number but 0 are always sig fig. Okay, and then for sig fig, I'm just going to put SF. Okay, and then here, I like to say any 0 between any number, actually, let's say any non-zero, actually, didn't want between numbers 1 through 9, and any zeros to the right of 1 through 9 with decimal. Let's see here, decimal are significant, and then any 0 to left, not significant. So what I mean by that, so if I say 0.00 number 00 number 000, so basically these numbers are significant. So I'm gonna put check mark. This is significant because they're any number but 0, and these numbers are significant because it's to the right and there's a decimal. But these numbers are not significant because it's to the left. Okay. Another key rule to this: if there's no decimal and there's zeros to right, not significant. So that's why up here I wrote decimal. Okay. Here, let's say you have number 0.000000, and since it doesn't have a decimal, the only significant number is this one. All of these zeros, they're not significant. We don't care about them. So that's your answer. Your little cheat sheet. I hope that kind of helps summarize this. And then I'm going to create a little cheat sheet for operation. Operation meaning like adding, subtracting, dividing, and multiplication. So if you're doing adding and subtracting, it's the answer. I guess answer will be will have the least decimal place. If it's multiplication and division, is the answer will be the least sig fig. Okay, so just remember, adding and subtracting is about decimal places, or number places, I would say. So just decimal places, and multiplication and division is the least significant number. And with practice, you'll get that. You'll just understand it. Okay, and here we go with the practice problem. So here, let's see. I'm gonna zoom in real quick right there. Perfect. Okay, I'm gonna write my little cheat sheet here, so I know to the right. I'm gonna say R with deci, and 0 to the right with decimal, and between number are significant. 0 to left are not significant. Okay, that's right. SF here and SF. Okay, so decimal. So here we have 1, 2, 3, 4, 5. But let's see if this 0 is significant or not. There's a decimal and it's to the right. That means it is significant. So that means we have 1, 2, 3, 4, 5, 6. So 6 sig. Okay. Here, let's look at this. We have 1, 2. So 2 numbers. And let's see if these zeros are significant. Okay. There's no decimal. That means we can't use 0 to the right row. That means these are not significant. So this is only 2 sig. Okay. Let's do number 3. There's 0 to the left. Usually, whenever I see 0 to the left, I cross them out right away. And I just looked at the rest of the number. And as you can see, we don't have any other zeros to worry about. So let's count it out. We have 1, 2, 3, 4, 5. So we have 5 significant sig. Okay. Here, again, 0 to the left. Just cross it out. Now, since there's a decimal here, I'm kind of going ahead of myself. Let's go. So cross those out, and let's look at these rest of the numbers. 7 and 3s are numbers, and there's a 0. And since there's a decimal, right, anything to the right with a decimal, any 0 to the right with a decimal is always significant. So this is 3 sig. Okay, so we have 1, 8, and 2, and we have zeros in between. And do you remember how any 0 between numbers are always significant? So we can count all these numbers as significant, leaving us with 4 sig. Okay, let's go to the next one. So we know these two are significant for sure. Now, is this 0 significant? We see a decimal, and 0 to the right of the decimals are always going to be significant. So this is 3 sig. Okay, same here again. We see a decimal and 3 trailing zeros. Since there's a decimal, we count these as significant, and these numbers also are significant. So we have 6 sig. Okay, next we need to consider these zeros. This 0 right here is between 3 and 5. This 0 is at the right of the decimal. Our first row right here said those zeros are going to be significant. So if we add them up, we count how many sig there is, there's going to be 5 sig. Number 9, there's a 0 to the left, cross it out right away. And now since there's no other zeros to worry about, we just count how many numbers there are. There's 3, so our sig is just 3. Number 10 has no zero, so we don't have to really like double check ourselves or like question ourselves if a number is significant or not. So we can just count how many numbers there are. There's 6. That means there's 6 sig figs. Okay, hopefully that will make sense. Now let's do 11 through 18. Okay, so for this, I'm going to do my work on the side here, and then just erase my work, and I hope you guys will double check your answer. Okay, number 11. This is multiplication, and multiplication slash division is sig fig, right? Least sig fig. Okay, so we have 23.4 times by 14 equals something. So number one thing before I continue solving this is don't round up until the very last number, or until you get the answer. Don't round up in between. And you get what I'm saying when we do question number 17 and 18. Okay? So number 11. Since this is multiplication, that means we're concerned about the sig fig, not decimal places. So let's count how many sig fig each number has. So this has 3 sig fig, this has 2 sig fig. And since we want the least, it'll be 2 sig fig in the answer. So if I multiply this out, don't round up, I get to 327.6. And since it's 2 sig fig, we go from left to right to count our sig fig. So we have 1, 2. We cut it off right here. And depending on what number this is, we round up or down. So we round up if it's greater than 5 or equal to, and we round down if it's less than 5. Oops. So since it's greater, we're going to round up to 2 or 3. So our final answer is going to be 330. And another tip, don't put 330 decimal. If you put that decimal, do you remember how decimal, oh yeah, I did not tell you guys this, sorry about this. Another rule to consider, if you have a decimal, any zero, okay, if you have any decimals, any zero to the left are significant. Or another thing you just remember is if you have a decimal, you can really think about it as like the significant. But since it's right there, this will be 3 significant figures. But we only want 2, so we don't want that decimal there. So our final answer has to be 330. I know this was a abrupt tip right there. So if you do have a question, please email us or just leave a comment. Okay? And we'll get back to you as soon as possible. So moving on to question number 12. So this is adding. So adding and subtracting, consider about the least decimal places. So we have 7.895 plus 3.4. Do you see how this has 3 decimal places, and this only has 1? So our final answer should only have 1 decimal place. So if I add this without rounding up, I should get 11.295. And since this 1 decimal place will be right there, cut it off right there. Look at the number next to see if we round up or down. Since it's 9, we got to round up. So our final answer is going to be 11.3. Question number 13. This is subtraction. So this is 0.005 minus 0.0007. So this is decimal places, right? Adding and subtraction is least decimal place. This has 3. This has 4. So our answer should have 3 decimal places. So if I subtract it out, I'll get 0.0043. 1, 2, 3. Cut it off right here. And we're going to round down. So our final answer is going to be 0.000. Oops, too many 04. Okay. Moving on to question number 14. This is multiplication slash division, which is least significant figures. So we have 7.895 divided by 34.0. Top here we have 4 sig fig. Bottom here we have 3 sig fig. The reason is the 0 is right of the decimal place, and those are considered significant. So that's why it's 3. And our least number significant is 3. So after solving it out without rounding it, I'll get our answer as 2.3220. 0.58824, right? 3 significant figures, 1, 2, 3, cut it off here, and we're going to round down by just looking at the number next door, so our final answer should be 0.232. Question number 15 is multiplication and division, and this is least significant figure. Here, we're just going to look at the problem as a whole, okay? Let me rewrite this. Okay, so for all the numbers, let's count how many significant figures there are. Top one, first number, we have 3 sig fig. We don't count these zeros. We count the zeros in between. So this is 3 sig fig. We don't count these zeros. That means this is 2 sig fig. And since we want the least sig fig, the answer should have only 2 sig figs. So plugging in this equation without rounding up, our answer without rounding up should be 4.68, 1625. And this is 2, 1, 2. Cut it off right here. Look at the number next door. Since it's above, we got to round up, so it'll be 4.7. Number 16. 16 is also thus multiplication. So we have 7.6 times by 104 times by 5.823 times by 10 to the negative third. Another tip, we don't consider this as a sig fig because there could be as many 0 before and after it, and it doesn't really matter. So we only will consider the non-exponent sig figs. So if we count the sig fig, we have 2 sig fig right here, 3 sig fig, 4 sig fig, and this doesn't matter any. So if our least number is 2, so our final answer and our should have 2 sig fig. So if I multiply it all out without rounding up, I should get 4.60249992. 2 sig fig, 1, 2, cut it off right there, and we round down because the next number is 0, so it'll be 4.6. Now, here we go with a tricky question, because it's a combination of addition of the two operations, addition, subtraction, and multiplication and division. So, if I see this here, we have 4 times 900, oops, let me write the number down. We have 4 times by 972 plus 76.4 times by 29.3 minus 12 times 7. Let's count for each sig fig. This is 1 sig fig, 3 sig fig, 3 sig fig, 3 sig fig, 2 sig fig, 1 sig fig. So, key thing is, you gotta multiply everything out first. So here, if I multiply it out, I get 3888 plus it by 2238.27 minus 84. And if you look at each parenthesis, this is for 1, so that's the least. So that means our answer out here should only have 1 sig fig, so that's our highlighted. Here, they both have the same amount, so our answer should have 3 sig fig, which is going to be 1, 2, 3, so right here. And then our last one, there's only 1 sig fig, that's our least, so our number should end right here. And when we add and subtract, it must be the least decimal place. So since none of the highlighted number are a decimal place, you want to choose the highlighted number that's furthest away from the decimal, which is going to be this number. So if we add everything, put 228.42 plus 84, if you add everything up, you'll get 262.10.52. You're just going to round it up to this number, because it's only 1 sig fig, and that's the decimal place that's furthest away. So I'm going to cut it off right there, and round it down to 6,000. Okay, here we go with our last question for this section. 4.1 times by 10 negative 3 minus 6.9 times 10 negative 2 divided by 72 times 10 to the negative 6 plus 8.943 times by 10 to the 4. Okay, here, sig fig. Inside, this is 2 sig fig, 2 sig fig, 2 sig fig, and then this is 4 sig fig. But the tricky part is the exponent, anything 10 to the exponent, will change the decimal places. And that matters because this is, in the end, it's a subtraction and addition. In subtraction and addition, the final answer should have the least decimal place. So if I write everything out here, so I will get 0.0.041 minus 0.069 all over 0.0000072 plus 89430 go something. Now, since it's the least decimal places, our answer right here, this is our least, this is only 3, this is 4. So when I subtract this out, I should get negative 0.600649. And since it's 3 decimal places, I'm going to highlight this right here. And divided by, I'm just going to put 89430, and then I have to add all that. Ooh. Okay, but the thing is, this number does not have decimal places, so our highlight number right here will be this one right here. So after adding it, we won't, okay, that's that. Okay, oops, adding it, we can just ignore this end part, because it doesn't really matter. So we only have like 89,000, but this is 3 sig fig, right, in the end, and after this rounds up, this is 2 sig fig, and we have to divide it out. And when we divide it, it must have 2 sig fig in the end, so our answer is negative 7.257, 10 to the negative 7 times it, and it cuts up right here, so it rounds up to negative 7.3 times 10 to the negative 7, and that'll be your final answer. And that'll be it for this section.